Okay, we start where Chapter 3 left off. We're going to start with the normal distribution. Remember in Chapter 3, you just had the test about it. You had three distribution shapes, three histograms. You had the skewed, right-left skewed, that you used Chebyshev's theorem with. And you had the empirical rule with what kind? What did you say? Bell-shaped, or what are the other two words? Normal, or one more? This is an important one. Symmetric. So within the symmetric distribution, that's the one we're going to look at. That's the normal distribution. So you're looking at that middle histogram where the mean, median, and mode are all three in the middle. And your goal today, your objective, is to make sure that we can get areas or probabilities from this table given one of 10 different shapes. That's our goal today, our task, is to learn how to use the table with any of the 10 shapes that we could get. And you'll see what I mean by shapes. Next time you'll see the applications and we'll go over the theory behind normal distribution and such. But today is just learn a skill and we'll apply it next class. So picture the normal distribution. You remember the histogram. There's one. Let's see, on page 301 if you want to look. You had your histogram. You only had one bar. It's unimodal. And if you drew a curve over top of your histogram, it would look something like that. Remember, you had your data. You built a frequency distribution. You had a relative frequency column. And the relative frequency column told you what percent was in each bar. Remember? What did the relative frequency column add up to? Remember? That was the frequency column added up to the sample size. Then we took the frequency divided by the sample size to get the relative frequency. And what did that add up to? 1. Or 100%. So if we were to shape the whole area under the curve, it's 100%. Or 1. And that's one reason why we can use it for probability distribution. That's just the sum of the areas in the bars. The bars are under there. And you can see if you take a larger and larger sample, you get more and more bars. And it starts to fill in all the space between the bar and the curve on page 301. So the first thing to remember when we're doing this today is the total area is 100%. The second thing, one of the properties, is that it's symmetrical. So if it's symmetrical, we could split it in half, and what area is on each side? 50%. So each half is 50%. For a decimal, 50% is what? 0.5. 1/2, 0.5. Okay? And in reading the table, you'll see they all have 4 decimals, so I'm going to write it. Second thing we need to remember is that half of it's 50%, or 0.5, while we're doing this today. Third, and last. The mean is in the middle. You'll find out next class why I'm going to put 0 in the middle. 0 is the mean for your normal distribution. We have to have a way to take any kind of data, whether it's heights or ages, and put it all into the same scale. So we turn it into something called a z-score. And 0 would be the mean for the z-distribution. And I'll show you the formula in the next class. But you're going to plot 0 in the middle. And it's important to know what area you're actually getting out of the table, which you'll see when we go through 10 shapes. The line underneath is your normal number line. That's where your class boundaries would be. It's a normal number line. So zeros in the middle, negative numbers to the left, positive to the right. Instead of an x-axis, we just call it a z-axis, but it's the same thing. The area or the numbers in the middle of the table, the shaded region of the number line from 0 out to some z, whatever z you choose. We're going to use these three concepts to find the area under the curve. Let's start with